The hydraulic system of an airplane's landing gear is a complex network of components that work together to extend and retract the landing gear, provide shock absorption, and support the weight of the aircraft during taxi, takeoff, and landing. Here's a detailed explanation of how it works. The hydraulic system of an airplane's landing gear is a closed-loop system that uses pressurized fluid to transmit power and motion to the landing gear. The system consists of several key components. 1. The reservoir. The reservoir is the storage tank for the hydraulic fluid, which is typically a synthetic oil. The reservoir is usually located in the aircraft's belly or wing. 2. The pump. The pump is responsible for pressurizing the hydraulic fluid and circulating it throughout the system. Most aircraft use an electric motor-driven pump or a ram air turbine, also called a RAT, to power the pump. 3. Hydraulic lines. The hydraulic lines are the tubes that carry the pressurized fluid from the pump to the landing gear and other components. 4. Valves. The valves control the flow of hydraulic fluid to the landing gear and other components. There are several types of valves used in the system, including solenoid valves, which are electrically controlled and use a magnetic coil to open and close the valve. Check valves, which allow fluid to flow in one direction and prevent it from flowing in the opposite direction. And relief valves, which protect the system from overpressurization by releasing excess fluid. Actuators are the components that convert hydraulic pressure into mechanical motion. In the case of the landing gear, the actuators are usually hydraulic cylinders, or sometimes hydraulic motors. The landing gear itself consists of the main gear, nose gear, and, if it's equipped, a tail gear as well. Each of these gears has its own set of hydraulic components, including actuators, valves, and lines. The extension and retraction of the landing gear is actually a pretty complex process, involving the coordination of several hydraulic components. Let me give you a step-by-step explanation of how it all works. First, when the pilot selects the gear down position, the following sequence occurs. The solenoid valve opens, which allows hydraulic fluid to flow to the landing gear actuator. The actuator, which is typically a hydraulic cylinder, extends and pushes the landing gear down and out of the wheel well. The check valve allows fluid to flow into the actuator, but prevents it from flowing back out. And finally, the relief valve monitors the pressure in the system and releases any excess fluid if necessary. When the pilot selects the gear up position, the following sequence takes place. The solenoid valve closes, shutting off the flow of hydraulic fluid to the landing gear actuator. Then, the actuator, which is again usually a hydraulic cylinder, retracts and pulls the landing gear up and into the wheel well. The check valve allows fluid to flow out of the actuator, but prevents it from flowing back in. And, just like before, the relief valve monitors the pressure in the system and releases any excess fluid if necessary. The landing gear is designed to absorb the shock of landing, which can be pretty significant. The hydraulic system plays a critical role in this process. Most aircraft use oleopneumatic shock absorbers, which combine a hydraulic cylinder with a pneumatic spring. During landing, the hydraulic fluid flows into the shock absorber, compressing the pneumatic spring and absorbing the shock. Then, after the shock is absorbed, the hydraulic fluid flows out of the shock absorber, allowing the pneumatic spring to decompress and return to its original position. The hydraulic system also plays a critical role in supporting the weight of the aircraft during taxi, takeoff, and landing. The hydraulic system maintains a constant pressure in the landing gear actuator, which supports the weight of the aircraft. It also transmits the load from the aircraft to the landing gear, allowing it to support the weight of the aircraft. The hydraulic system provides damping, which helps to reduce the oscillations and vibrations of the landing gear during taxi, takeoff, and landing. The hydraulic system of an airplane's landing gear has several fail-safe features to ensure safe operation. Most aircraft have redundant hydraulic systems, which allow the aircraft to continue operating safely even if one system fails. Many aircraft have an emergency extension system, which allows the landing gear to be extended manually in case of a hydraulic failure. And the aircraft is equipped with warning systems that alert the pilot to any issues with the hydraulic system, such as low pressure or excessive temperature. In conclusion, the hydraulic system of an airplane's landing gear is a complex and critical system that plays a vital role in the safe operation of the aircraft. Its ability to extend and retract the landing gear, provide shock absorption, and support the weight of the aircraft makes it an essential component of modern aircraft design.